So thanks for coming. I wanted to do this particular talk for people who especially are just getting started. So I'm assuming everybody went to Jonas's keynote yesterday. What I hope this talk will help to do is bridge the gap between principles and what a modernization project actually looks like in the real world. So this is a little image that I think represents how to get started. So if you're familiar with Everest expeditions, everybody talks about the summit. But actually the most dangerous part of an Everest expedition is the very first time that you leave base camp and cross this thing called the ice fall. And so that's actually where more of the injuries and accidents happen. So the reason I like this kind of analogy is the amount of prep and the amount of patience to get to the summit is way more important than the summit itself. And having been through a lot of enterprise modernization projects with very complicated existing systems, I feel like there's a few techniques that I've picked up over the years. I started with Scala in 2008 and started with what I consider very deep reactive development in about 2012. Previously, I was working with Lightbend. Now I have a consulting company. And so, yeah, this is after a lot of projects and a lot of struggles. I'm gonna maybe give some of that to you guys, basically, so you don't have to go through it yourselves. So it's kind of a why. Why do we want to modernize to begin with? Well, enterprise software has evolved radically more slow than the market itself. I'm sure we've seen some stories that have come out in the news, the impacts of a lack of modernization, perhaps not taking it as seriously as it is. Hands up if anybody can give me the most common security vulnerability in enterprise software. You want to take a guess? I'll answer it for you, because that's what I'm here for. The most common vulnerability is an inability to apply patches quickly. It's not a complex series of lateral escalation attacks. Those exist as well, but what an attacker needs to do is get a foothold inside your system to begin with. So there are huge amounts of risk. There's a story with Equifax that was in the media recently, and the speculation is that attackers got a foothold because of an unpatched version of Apache struts that was quite out of date. So modernization isn't a nice to have, it's a must have. And I think that the longer that a modernization project is delayed, the more costly it can be on all fronts. Hiring the best, right? So a flight of talent can occur with a system that's not pleasant for developers to interact with. It can be a security vulnerability. It can respond slowly to business demands and market changes. So basically what we're moving away from are systems that kind of look like this. I grabbed this off of the net, so hopefully it's none of your systems. But you can go to the daily WTF if you want to see more of this. How many people work with a system that kind of looks like this? Cool, so you're in the right room, because we're going to talk, we have some things to talk about. No.
Several systems like that.
Yeah, so the reason that these systems are so challenging to work with is because they're literally unbounded in complexity. For anybody I spent over 12 years working with large banks, and it was much more common than not that I would walk into a new team or a new company and look at a system like this and have to start making patches and have to start making enhancements. And quickly you realize that, let's say I touch something in the top right, it probably just broke something in the bottom left, and I have no idea how. So really, we want to move away from systems like this. Forming a complete mental model of this system and all of its side effects and all of its cause and effects is impossible. So I would actually say from a developer, from a tech perspective, the reason we want to move to events and we want to move to what Jonas talked about in his keynote is because we can actually simplify our models. We can actually architect software in a way where we can fit mental models of what we're responsible for in our head. and perhaps even with the team as a collective. Then there's the infrastructure side. Usually at best, there's this kind of crude active-passive. There have actually been some pretty well-known failures. I'm not going to get into it, but there have been some failures in the media where if you start to of very large companies where you look at it and it's like the failover mechanism failed, right? So we might have active-passive and we might have an ability to fail over, but in one case in particular, there is a case where the power generator on the switch that does the failover actually was down. Nobody could figure it out, and the company had to shut down for a few days. No biggie. And then even if you manage to really ace failover, then you get into some pretty complex state replications and things like this. How many people have worked with things like WebLogic or WebSphere clustered? Yeah, is it fun? How many people found that really fun? No hands. Yeah, it's not. I've done enough of that to kind of know that, you know what, it's not that it's fun or not fun, it's that it's difficult. And when I struggle with something, I kind of like to ask myself, is it really, am I getting it? But what's interesting is I believe it was WebSphere, the inventor of WebSphere actually came out. Now he's with CA Technologies, and he more or less admitted that he made a mistake trying to fit so much into one product. And a lot of those early containers suffered from the same kind of complexity in terms of building high availability systems. So that's what we really want to focus on, is HA. So as you start with a modernization project, it's really important to focus on the goals to avoid all sorts of going down the rabbit hole and trying to solve problems that should be incremental. So although some of the techniques that we'll introduce here are probably new and unfamiliar, we're not doing it just for the sake of learning something cool. We're doing it actually to reduce the brittleness and the complexity of that, especially that first software model that I showed you. And the way that we get to that is we take this unbounded complexity and we start to put some well-defined boundaries on it. We do things like even revisit our existing assumptions and start to look at the business processes that are involved. Ideally, when we get to that, not only do we have some really well-defined boundaries in our software, it becomes more pleasant to work with. We can start to move systems from batch to real time. We can be more confident in the changes we make. We're not afraid of our systems anymore. But that being said, it's not all gravy and roses and all these other nice things. These are still emerging technologies. I would say that you should stay skeptical of all the things. Look into the principles, especially when you're going through text selection. I think that right now there's a lot of redefinition of terms. There's a lot of emerging sort of I'll say emerging terms like serverless, right? I mean, well, there's a server somewhere, right? It's just that you may not be responsible for it. So it's just, kind of like separating apart the hype and the buzzwords from the things that are real and then tying them back into what your goals are. So what I would just say is, especially over the next few years, is don't be afraid to ask the hard questions, especially when you're choosing technologies. So, let's get into the meat of the talk, and that's what some reasonable first steps are on a brownfield enterprise migration. So a lot of the material in the reactive space is super focused on greenfield, but my entire background in software is on large-scale brownfield enterprise projects. So there's some awesome techniques that are actually not necessarily emerging. They're actually proven out. But we'll start with events and sort of tie in this talk to what Jonas was talking about yesterday, but then show the how. And the how will be presented with a technique called event storming. Then we'll get into domain-driven design, what it's good for, why you should adopt it as a technique. And then we'll get into that nitty-gritty, right, which is actually quite a bit of the training I do and my company is translating those models into actual requirements. How do you actually make these things happen? And then finally, we'll get into some pretty cool code, mostly in Java. I snuck a little bit of Scala in there because I couldn't help myself. OK, so without further ado, let's get started on events. Events are actually fairly simple. This is why they're a beautiful model, a beautiful abstraction to start to rethink your enterprise systems, because they're simply interesting things that have happened in the past. In terms of abstractions, this is the easiest way to speak to the business. Is imagine if every interesting fact or event that's happened in your company were emitted, and any other team could simply subscribe to those events and build their own functionality from them. You would actually have a fairly robust enterprise system without a lot of communication coordination costs. Events happen, so it's up to people to subscribe to them. This is actually like pretty much an inversion of command and control. The reason that's so nice is because if we were actually like doing a direct sort of like one-to-one sending these as commands, we might actually have to coordinate with a ton of teams. This way, it's just like the ordering team is responsible for orders, and that's it. They emit when the orders are successful. So they're not reaching into other people's areas of responsibility and trying to force things to happen. They're simply doing what their task is. So it's a great abstraction, and this is what it kind of looks like. Interesting events published by default. You can do things like build an event catalog off of things like this, just as powerful as well-published APIs. But this actually becomes part of your application programming interface. This is a small example of you could have any kind of, I'm not going to get into the technical side of things right just yet, but really you could have n number of systems that are actually observing order placed. So talk about coordination costs. Imagine if you're already integrating with this paradigm. Now you spin up a 5-person or a 10-person data science team. They don't have to speak to anybody. They go to the event catalog, they see what interesting events are being emitted, and they can do their data science based on it. So that's as your company and as your architecture grows in complexity, having these very well-defined boundaries, but also containing the responsibility within the boundary is really critical. This isn't new. Jonas mentioned this. This is an anecdote. I've worked quite a bit in finance. I worked on personal checking account systems. And this type of system, I actually started my career as a COBOL developer. And interestingly enough, how many hands up? Has anybody here done COBOL, JCL, anything like this? Wicked. So, I mean, you're basically emitting from one job to the next. You're not like reaching into the guts of another job. So, like hypothetically, let's say I'm a customer. I go to my bank and deposit a check. I don't deposit the check. I certainly hope that the bank doesn't take my check, go to some shared ledger, like legit erase my balance and just pencil in something new, then throw the check in the bin, right? That would probably be bad. No, what they do is they have a journal of all my deposits, all my withdrawals, and eventual consistency on what my current balance is. And it may be a little out of date, but that's okay. We're comfortable with that. In a lot of areas of our lives, we're actually very comfortable with eventual consistency. It's actually more in terms of development when it starts to get hairy because we don't trust it as much sometimes. Now what's interesting is if we have the series of all the interesting events that happen within our system, we can actually start to insert intention into those flows. And this is something that when I always start, even if there's an existing system, even if the requirements are well-defined, I always start with this. It's amazing if you go and revisit a business process that's been around even for like 10, 15 years, sit down with sticky notes and just start to like event storm this out. The storming session can come out radically different than what anybody thinks the existing process looks like. So in a way, you could actually stop here. I've done event storming sessions, never written any code out of them. It's literally just to visit our assumptions and almost like audit what we think is happening in the system. This is a quote that I really like because this is the key thing, is to reduce complexity, to bound complexity and reduce unintended side effects. we want to be able to know why a system is doing what it's doing. So as we start to model out commands, events, we have actually quite a large vocabulary that we can use. We can use these things called reactions that I'll get into, but everything is additive only and completely immutable. So once we start to be very transparent about cause and effect, we start to reduce the fear, and events can help with both of this. So an event storming session, how many people have led or been in an event storming session? Only a few, so they're actually really straightforward. You need a wall, and you need sticky notes, and you need a team that really cares about either a new brownfield project or simply wants to revisit some assumptions. But the result of the event storming session is less important. It's a communication tool. So I've been in. I want to share an anecdote. One of the coolest event storming sessions I led, actually, an executive at the company just happened to walk by the room, saw that all his people are throwing sticky notes all over the place, and thought it looked fun. Came in, joined the storming session, and actually spent the whole day in our storming session. And this is somebody that's responsible for pretty much the whole system, and began to learn about the system they're responsible for. So that was pretty cool. So basically, once you have a room, you have some sticky notes, you need a wall. Does everybody have those things? Cool. If you don't, I can't help you. You're working outside, so you'll have to lay your sticky notes down on the ground. What emerges from these sessions are actually fairly complete. It's amazing. 2 days with enough people at all different levels of seniority in your organization. And if you remove titles and fear and all of the things that go into inhibiting communication, you get some pretty cool results. So what I would say is that what you get is not only I would say the biggest difference between event storming and more traditional forms of modeling like UML is you've actually removed all the complexity from the vocabulary of the session itself. If you just have different color of sticky notes, there's no ceremony, there's no complex UML book you have to hand to somebody and say, hey, go study this for a weekend. I mean, I can introduce the concepts of event storming in about 15 to 20 minutes, and then we're working right away with people that have never done it before. And within an hour or two, you'll have pretty complete event flows starting to emerge on your walls, which is neat. Not only happy path, but sad path. If you have the right mix of people, there's inevitably going to be one person saying, oh, wait, if this happens, then this other thing is probably going to happen, and what if? And you'll get into a lot of these also sad path discussions. So what I just want to point out, what's really interesting too here is on the very left, we have a command. We've attached a happy little person. I'm like the Bob Ross of events. A happy little person here on the left. And you see the lavender sticky. That's actually called a reaction. It's actually the exact same thing as a command. It's just we can actually be more specific. We can basically say commands are initiated by users. Reactions are initiated by the system. They're kind of like the same thing conceptually. But if you have a large UI UX team, using the extra color of sticky notes to differentiate, make it very clear where the responsibilities lie. So you can have these nice flows, and if you're using both commands and reactions, both back-end and front-end teams can see where their work is going to begin to emerge. But we haven't even talked about tech yet. The great thing is you can stop there, and you've probably had a very valuable conversation internally. Where we need DDD is inevitably, guaranteed, any kind of meaningful business process spans organizational boundaries. So tech does not live in a bubble. It interacts with all sorts of things. It interacts with change management, ITIL. It interacts with all forms of org charts and hierarchies and so forth. So we can leverage DDD to start to model very clear boundaries. So in this case, this is just again, a happier diagram of bounded contexts. We see that events are flowing across 3 bounded contexts. Our order system, our payment system and our shipping system. So that's it. I mean, that's really the complexity of bounded context. And so again, you can explain this to a group of people that have never done it, and you'll come out productive within an hour. So, so bounded context we'll circle back to, because I want to tie them in, but the only thing really missing from our event storming exercise is the fact that in any kind of system of meaning, there's state. So we need to model that state. What DDD does is give us the concept of aggregates. So what we start to think about as we bring more tech people into these sessions is, let's say I have a submit credit application command coming from a user. There's probably some kind of state that it's acting upon, trying to influence. In this case, it's a credit application. We want to submit a credit application. And then there's an application submitted event that emerges from that. The credit application, then it can actually start to get more complicated. As we start to throw sticky notes down, what will start to emerge are these hotspots where you'll have these root entities, and they'll start to have lots and lots of commands and events that are attached to them. What I love about sticky notes, there are only so many of these commands and events that you can stick on one root entity. So it forces you. It's like the Montessori school of application architecture, right? Like you're also bounded by the physical reality, how big these sticky notes are. So you have to justify. You have to justify, and you tend to keep root entities or aggregates very small. And that's good, but that being said, the goal is when you start to model your flows out is to start to relate start to pull together all the related concepts, and boom, that's your aggregate. And then you can start to implement it, and we'll get into that. When you start to have a number of aggregates, this is where event storming starts to flow deeper into the world of DDD, and then you may have multiple teams in a room together. And then you'll actually start figuring out structurally where different aggregates are, who's going to own which aggregate. These are valuable conversations to revisit. If you need to, one of the things that this also does is it helps to create a model of shared concepts. So one of the key things that comes out of DDD especially is this thing called ubiquitous language. If you name things appropriately, you avoid the kind of like dreaded, payment, customer, impl, like you're not mixing different concepts from bounded context in your naming of aggregates, right? An address is an address. You may have, I don't know if you can see this, no. You may have an address in shipping. You may have another address in payments, and it's fine. You can actually duplicate. Even though it's the same name and the same concept, if there's any delta between the two, you're not going to try to share those entities. You're going to have separate ones. But then you start to get into this nice thing where the boundaries that you've created lead to enhanced communication. The payments team can speak in their language, and really, it's just the API that they would need to understand when they're interacting with other systems. But an address within the payment context is an address, and it's well understood. So yeah, a single team can master an entire bounded context. A single person should be able to master an aggregate. Like I should be able to hand an aggregate to a developer, and the mental model is tight enough that they can be productive with that aggregate pretty much right away. So now, let's hypothetically say you've gone through this whole exercise. You have stories. How many people work with stories, user stories, anything like this? Cool. So yeah, it's actually quite easy. You start to pull apart. So typically, what we do too is we attach some kind of paper to the wall, and you can actually start to tear pieces of paper off that have the sticky notes applied, and then just take them over to your desk and start to write some requirements and throw them in Jira. But it's quite easy to start to map these. So for instance, this is pretty easy to understand. And then also I can start to add things. In this case, here's a nice thing that I do sometimes, which is on reactions, use when then. So it's when a cart is abandoned, then I would like to follow up with an email. But I don't need to artificially add a bunch of commands in between there. And I've got Alberto Brandolini is really who coined a lot of this, a lot of these concepts. So I'd also highly encourage reading his book called Event Storming. But you can also add a little timer to pretty much anything to kind of signify that maybe it's not directed. Maybe it's happening based on a cron job or timer or something like this. And then you can also quite easily sort of map this to acceptance criteria. So it's a really complete end-to-end going through the communication exercise with your teams, then working with your PMs to put a lot of this work into Jira. Very effective in terms of productivity to get started. So you've gone through all of these exercises and now you're ready to code. It turns out that Akka is the perfect abstraction for an aggregate. The reason for this is because there is no way to reach into the guts of an actor. How many people are familiar with the actor model? Awesome, great. Okay, so I'm probably preaching to the choir, but I'll keep doing it. That's what I got. What's fantastic about it is the models line up both conceptually, physically, logically, everything. They're kind of a match made in heaven, and this is basically how I default to application architecture. But putting the boundary physically here and not allowing other aggregates to reach into the guts of yours and just start directly manipulating your state and things means that you always have a mailbox. You always have some kind of defined path where you have to receive a message in order for state to be manipulated. And what's really cool is that you can actually leverage some features of Akka to make all of the commands and events that are coming into your aggregate durable. So in this case, this is an example in Scala. This is the Scala I snuck in. In this case, we have an add item. So we have a cart. So cart is effectively the aggregate here. And we have an add item. We have an add item command that we're able to process. So if we do receive an add item command, we can actually persist this to a log. Now, what's interesting is there's a real nuance here that I'm going to throw out there. It's way out of scope to cover in depth, but in this case, I'm actually not persisting the command. Just for anybody that knows, what we're doing here with this line 2 is we're leveraging Akka persistence, where this shopping cart can be named, it can live in memory, but it can also be durable. If the node that cart lives on crashes for any reason, that cart can actually spin up on a surviving node in your cluster, and all of the events are actually played back, and the state will return to as it was when it crashed. So when Jonas mentioned that you don't need to rely on mutable or relational databases to maintain durability in state, this is really what he's talking about, is you can keep all of the state associated with that cart in memory where it's going to be acted on, but it's also durable if the worst happens. You can get back to that state. So in this case, what I'm doing is actually creating first the event, which is item added, persisting the event. So this is really important. This is event sourcing. A lot of the code reviews that I do, you'll see a mismatch sometimes between event sourcing and something else called command sourcing, where if I just take the command and persist it, it's not quite as deterministic because I still have to apply the command. So I'm applying a number of commands when I'm recovering, and I can't guarantee determinism. But if I'm persisting the events, making sure they're safe, I can just replay the events, and it's quite a bit more deterministic when you're recovering from a crash. And then I simply emit the event. And then we'll have a lot of other logic. In the case of, if you remember the event storming flow, there is if the session is abandoned, I want to send an email. So there's another process that would check for abandoned carts, perhaps even being emitted events all the way down from the UI. I'm a huge fan of a tool called Aurelia. It's a completely event-driven UI framework, and you can actually have this completely event-driven architecture all the way from your UI. And listen on things like abandoned sessions. So this is the sort of visual representation of what the event log would look like. Is in this case, we have our service endpoint. You can consider that the API. Play is a fantastic way to implement this, but you can use pretty much anything to implement your API. You can use an API gateway, pretty much anything. And then you can have your durable actors that represent aggregates, and each one of them is backed by its own event log. But the interesting thing is, let's hypothetically say you're using Cassandra. How many people are familiar with Cassandra? Awesome. So if you're using Cassandra for this, the event log is actually replicated also across your cluster. So as long as you're actually configuring Cassandra properly, you're not guaranteed anything in life, but you're reasonably safe from catastrophic failure in this case. Now, if any of these aggregates is on a dying node, they can come back from the event log on a surviving node. So this is kind of what it looks like. Is you may, for scale or resilience, you may have a number of service instances in front of your stateful actors. And a little more complete picture of this is the play architecture itself, and why it kind of lends itself so well to what we're doing here. So if you've noticed, I haven't used the word microservice once yet, I don't think. Have I said microservice yet? No? Okay, I'm falling behind, I'm just kidding. We're not even at microservices yet. We are completely rebuilding, we're completely modernizing our system, actually by building our target system as a monolith. And I'll talk about the advantages of this, but Play is a phenomenal technology to do this in, because you can see that we have our models in our domain, and I'm going to get into some techniques on how to model a very clean domain. Before we get there, though, when I talk about the ability for a node to crash and for aggregates to pop back up on another node, what I'm actually talking about is Akka cluster sharding. So effectively, you're taking the size of your cluster and you're deciding how many aggregates I want to spread across the cluster. What's cool is this automatically rebalances itself. So if you provision new nodes, say in EC2, for instance, your aggregates are actually going to rebalance themselves. There's a little bit of things to do in terms of deciding how to place aggregates across shards, but yeah, it's very doable. So you don't have to care about their physical location at all. You interact with them using their logical identifier only. This is what it would look like in terms of more end-to-end. You'd have a service that might issue a command to a specific cart, because I've looked up where users, this particular user that I'm dealing with, their cart is actually located. So in this case, I'm dealing with cart B. Akka cluster sharding is going to tell me that that cart lives on server 1. So I'm going to get a reference to it, and then I can send it a command, and then the item added event can be emitted to, not to be mistaken with the event log for the aggregate. This would be perhaps a domain log of events using something like Kafka. So you can think of this down here as something that is actually where you're actually sending business events, not necessarily just the messages into the aggregate for durability. So the event log itself is where others can actually observe. You could have any number of systems that come across. This could be a topic in Kafka. This could be the cart topic, and anybody that's interested in cart events can subscribe to it. And that's completely disintermediates point-to-point connections in a large system. So there's no coordination cost to observe a log. And this is what a little more of a complete picture looks like, what you would see. And I added, just to again show the nuance between, and this is a Java example, but in this case I'm actually persisting the command. This is valid and it will work. There's just a trade-off, so I wanted to show both. But in this case, yeah, this is basically looking up a cart and applying the command, and perhaps we would want to emit an event to Kafka. This sender tell just basically sends back to the service that we're done applying the add item. So let's get into some patterns for modernization. When you start to structure, like we haven't talked about microservices at all for good reason, because they're actually a refactoring pattern. They're not necessarily what I would go to first off. They do introduce some complexity. Like distributed systems are by nature more complex than localized systems. So what I would say is to focus on getting a monolith even structured properly. My personal feeling is if you can't structure one service, you probably can't structure 150. So I like to work with my team or work with a team and as I'm learning new things, understanding the domain in this kind of fashion. So onion architecture, how many people have ever leveraged this in the wild? Sweet. So there's some, are you all true believers in the onion architecture? How many true believers do we have? Yeah, big hands. Cool. So we got some. I want to make more true believers out of the onion architecture here. What this is probably like when you're looking at a single application and there's a ton of complexity in it. It's because it's more or less violating this principle. You may have the core domain of your business logic reaching out to infrastructure code to do something. So in this case, in play, what we're basically saying is we want more or less decorate our calls through the architecture with the things that they need as they work their way into the core. But what it means is that the core of your system, which is where your business logic actually lives, should never call outwards. So your core should never depend on the domain should never depend on the API. It's only the other way around. And once you follow that more or less to a T, and if you leverage features in play like dependency injection, you can actually have very pure domains, which would map to bounded contexts, which is why I love onion architecture and DDD work really well together in terms of very cleanly implementing what you've modeled. So in this case, we just have a monolith, but it's very well structured. There's no scenario in which API is going to depend on anything in controllers, and there's no scenario in which core is going to depend on anything outside of the core. So in this case, we see that we have 3 bounded contexts. What's really nice, I'll talk a little bit more about this, but when you do migrate to microservices, your APIs for your bounded context can stay in place, and what you wind up with is actually a free API gateway. You simply pull the cores out, move them into a microservice, then the implementation inside the core actually just becomes proxy code. So I've leveraged this very effectively. So you may have 2 bounded contexts that are still within the microservice, and you've moved one out to a microservice, and then the core just becomes communications code. So there's another pattern that should be going hand in hand with this, and this is a tricky one. This is like, pretty much the #1 cause of tears, I would say, on a brownfield project here, is anti-corruption layers. So I'll get a little more into it, but when you're kind of like living in the real world, you may have systems that are non-trivial. I've worked on some very non-trivial systems. You don't want to throw everything away necessarily. But it's that first step. It's that like we've created a new service. That's great. How do I interface it with the existing system? I'm probably going to have to start to make changes to the legacy system to make this work somehow. The reason that winds up ending in tears is we're back to almost the very first slide that I showed you, where if you start messing around with your legacy system, you have no idea what kind of cause and effect is happening. So not only do you have perhaps not stable first release in your microservices, which is, can happen once in a while, but you also introduce instability into your legacy system, and this is a big reason, this kind of combination is why a lot of projects are shelved. So instead, what we want to do is we never want to change anything in the legacy system at all. The anti-corruption layer actually gives us a place either physically to add, so we can actually start to copy and paste code. It sounds a bit ugly, but imagine in your legacy systems that you work with, you simply put an API in front of it. That's the way to think about it, is what would I need to do to make this API work? So you can introduce an anti-corruption layer into that architecture. I've actually created a whole new service for it in the past where I don't even have source code for the existing system. And that's where I can just make things work. And it does work. I'll introduce, where this goes. Don't worry. The idea is that the anti-corruption layer is temporary, but it's just one of these real-world patterns you can look up and get more details about, but really critical. And the reason that it's so important is because most legacy systems are actually nothing more than a series of transaction scripts. How many people are familiar with the transaction script pattern? Well, anti-pattern. Transaction scripts. Has anybody, okay, I won't even make you put hands up here. But a transaction script would be, and I've seen a lot of these, go into a new system, go into a new class, maybe it's enterprise Java, go into a JSP file and see like 6, 7, 8,000 lines of code. That's a transaction script. Without the anti-corruption layer, teams will actually cut and paste these transaction scripts into the new microservice, and then it's like, not ideal, not ideal. So what we want to do is decompose all of this legacy stuff into our new services, what we can save, what's good, clean code modeled into aggregates, those pieces of code that need to live temporarily while we're doing this migration can be decomposed into an anti-corruption layer. Stabilize the API, focus on the API. As long as that's clean, you can even cut and paste some of this code. And I've absolutely had to do that. But the reason it's called anti-corruption is it's not coming into the new code and corrupting it. So there's one more really effective pattern that I leverage on these types of projects. So now you've got things modeled. You've got your target system is started with perhaps a play Akka monolith. You're working on the API. You've got anti-corruption layers, but now you really want to start moving functionality, business functionality, even like interfaces for the user experience from the existing system to the target system. That's where the Strangler pattern comes in. And so it was named after the Strangler vine or the Strangler fig, which is really cool, actually. It's a tree that effectively grows over an existing tree and winds up basically killing the old tree, and the new tree is hollow. And that's all she wrote. Nature is kind of freaky. But it makes for a really good modernization pattern because this is what it kind of looks like. We're back to our conceptual diagram here. We have most calls. So this top orange box, let's say that's your load balancer. There's a few requirements here. The existing system should be web-based for the Strangler to work, and it should have standardized URL patterns. But what I can start to do is, in the existing kind of world, I can say maybe matching on URIs. I can say, okay, everything for the whole system is going to go to the existing system as we're working on the new build. But over time, I'm going to start to build out the new build and sort of match. I've used like regexes literally on different URI patterns and served up end-to-end new functionality where literally it's like a brand new UI even. And over time, you're going to just keep going. And what's interesting is as you work with the Strangler pattern, you may also, and probably very naturally, be refactoring that monolith that you started with, that play Akka monolith, into microservices wherever it makes sense, for team structure, for productivity reasons only. So I think these two patterns also very applicable in the real world, and this is kind of what it would sort of look like as you're working with your Stranglers. You may want to move product into a microservice at the same time, and yeah, very natural kind of relationship between these two patterns. So I'm going to round out the talk with the goal. Like, let's tie it back into goals, right? I mean, there's the dev side goal, which is we want to reduce complexity. But the Linux Foundation has coined what it means to be cloud native. So there's also, like, the infrastructure is actually the huge value. I mean, you can radically reduce compute cycles and complexity in your infra through these modernization exercises at the same time. So perhaps as you're working with your Strangler pattern, your existing system lives in your data center, but the new build goes into something like AWS or maybe on-prem cloud. And Really, you just have to have three things in place for the new build, which is being container packaged, dynamically managed, which I'll talk about a little bit, and microservice oriented. Oriented, not microservice, period, just microservices oriented. For some of the infra teams, there's a little bit of a curve to get containerized. There's really not a radical difference between what we've been doing for a lot of years with VMs compared to what we're doing with containers. Really, the reason that this is important is because microservices need to spin up very fast. You're working in a dynamically managed cloud environment where a node can just die. So by reducing the need for guest operating systems, you actually can speed up restart times, because that's one of the key requirements for a new build to live on cloud infra. I believe WebSphere average startup time is something like 120 seconds, at least last time I worked with it. That would cause some issues if your cluster is large enough and non-trivial enough and sort of like nodes kind of dying and coming back. So something like Docker just reduces that startup time. And then you wind up with something like this, which is the target. High availability, resilient, and scalable infrastructure where you can have orders and shipping and all of your different bounded contexts or your different microservices spread across a cluster that's changing based on demand, changing based on things like failure. And finally, it also gives a huge benefit to teams. So back in my COBOL JCL days, the picture on my left here was pretty much par for the course, right? Hey, I need a new feature in this other app. Okay, 14 months we can get that ironed out for you. Whereas once you move to this kind of new architecture and infrastructure, it just reduces the whole overhead of coordination. And radically increases efficiency. So in conclusion, I'll just recap some of the business value, which I think is very important, right? Is that we can use event storming to revisit our prior assumptions. We can transition incrementally. I think this is without destroying our existing system. So if somebody says, hey, microservices are risky, what you've done is you've mitigated the risk by saying, well, we're not even going to touch our existing system. Worst case scenario, we can A/B test it. We can move back to it if we have to. So you gain cloud readiness incrementally and get the most out of microservices. Really, like what I think their biggest value in real world. When you start looking at, I've worked on systems with hundreds of microservices, and they're great as a structural pattern and a refactoring pattern. But I think the key in that is remembering that microservice oriented, not just microservices as a rule. And you can break the chains of the past in your existing architecture, so respond faster to business demands, and that's really what it's all about. If you want to learn a little more, you could stop by my booth. I'm Red Elastic, and have some free copies of the book that covers this and a bunch of other things from O'Reilly called Migrating Java to the Cloud. There's also a white paper that I collaborated on with Lightbend, and it's all about these sorts of topics at a higher level for financial services. So if you're interested in that, you can check out Lightbend's white paper section. So thanks very much. I'm right at the end. I'll take maybe like one question, but you can always catch me at the Red Elastic booth. Any questions? Cool. Swing by for a free copy of this then. Okay, thanks very much, everyone.